This is video CA7. If you're following along in the series, we're going to cover the topics of nth roots and rational exponents. In the textbook that I'm using, this is from pages 53 to 55, and there will be a link to that textbook down below. So let's get started. Just a few terms we need to go over before I get into working the examples. Nth root. This is just a general term that refers to any root, any index. You know, we got specific with square roots, so now we're branching out, so you can have any number there, and that number is referred to as the nth root. Now, the technical definition of the nth root is, the nth root is the number, and that's going to be your answer, when multiplied times itself n times equals a, which is the number under here. So in other words, if I have b equals n of a, b is the nth root. If I multiply b times itself n times, I will get a. But this is the root. We have one more. The principal nth root has the same sign as a. It's going to have the same sign as the number you start off in here. Now let me give you a little warning. The problems in this section are carefully selected so that you don't have certain problems. And one of those problems is a negative radicand under a positive index. That results in a complex number, and we will cover that in section 2.4. So when we get there, and I'll say, oh, I thought we knew everything. You don't really, but we're going to cover a whole lot of stuff. Now let's do some examples. Example 10a, page 53. I need to find the fifth root of negative 32. Alright, since this is negative, my answer is going to be negative. And I have to ask myself, what number can I multiply times itself 5 times and get 32? Well, it's going to be either 2 or 3. So just check them. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's all there is. You could use a calculator on this, and I'll show you how to do that in just a second. Example 10b on page 53. We've got the fourth root of 4 times the fourth root of 1024. Now, I know for sure 4 is not a perfect fourth of anything. So what you want to do here, since your indices match, let's combine those under the radical sign first. So we're going to have the fourth root of 4 times 1024, which is 4096. Now, is this a perfect fourth root? Well, I don't have my fourth roots memorized, so this is going to be a calculator problem. Different calculators are going to work differently, so the key is to know your calculator. Before you spend a lot of time learning a calculator, make sure that that calculator is acceptable for whatever test you're preparing for or whatever class you're taking. Now on the TI-36X Pro, to find the fourth root of 4096, this little button in blue up here is your nth root button. If you look at the little blue mark right above the x squared, that's your square root. That's just a quick way. So if you're just finding a square root, you would want to use this button. This button. But we're going to be using the button above the x to the little square. So hit your index button first. So I'm going to hit 4, then the second function of this button. Now you see I have a fourth root and the radicand part is blinking. So I can push 4096 and then hit enter, and it shows me 8. So final answer is 8. Example 10c, page 53. We have negative cube root of 8x to the 6th over 125. Since all of this is under the radical, first look and see if this will reduce down. 8 and 25 don't have a common factor, so it's not going to reduce down. The next best thing is let's split it up. Now your answer is going to be negative no matter what, so we'll just leave it in the numerator. So now I have cube root of 8x to the 6th, and I'm going to do cube root of 125 on the bottom. Now, How am I allowed to do this step? That was your quotient rule. So they're just checking to see, do you know your rules? It's not so much about the math as do you know your rules? Well, you just exhibited you did. Now let's simplify. Like I said, my answer is going to be negative. Now, what's the cube root of 8? Well, that's 2. And the cube root of a variable with a higher exponent, remember I told you, you can divide the exponent by the index. So 6 divided by 3 is 2. That's x to the second. Now down here on the bottom, what's the cube root of 125? Well, you should really know your first few cube roots. But if not, I mean, just think about it. You've got to have a number that you can multiply times itself 3 times and get 125. Probably going to be a 5, so just test it. 5 times 5 is 25, times 5 is 125. So the cube root of 125 is 5. 2 and 5 will not simplify, so this is going to be your final answer. And here's example 10D from page 53. 8 times the 4th root of 3 minus the 4th root of 48. So let's look at these. There is nothing here that will simplify. 3 is not a perfect fourth of anything. So let's look over here. I do like, right off the bat I see that the indices match. So that means there is a possibility that I can combine if my radicands match. They don't right now, but I look at 48. Can I simplify that? Well, what you need to do is look at your index. It's a 4. Is there a perfect fourth that will go in here? And I just jotted down, all right, my 2's. 2 squared is 4. 2 to the third is 8. 2 to the fourth is what I would be interested in right now, and that's 16. So is 16 a factor of 48? And of course, yes it is. 16 times 3 gives you 48. So let's come down here. Nothing here is going to change, but I am going to break this up into 3 times 16. Now, what's the 4th root of 16? 2. So on my next step, this will not change again, but I can pull, the 3 is going to have to stay under there. I can pull the 4th root of 16 out. Now when I pull that out, it goes outside of here. So this is the simplified version of 4th root of 48. Now my root part matches, so I can combine the coefficient or the front factor. What's 8 minus 2? 6 onto the 4th root of 3 is your final answer. That was all for nth roots, so let's move into our second topic, which is rational exponents. That's going to be exponents that are fractions. And this is the point where exponents and radicals kind of come together. They have a connection. We have one rule, and the rule is a to the m over n. So m over n is a fraction equals the nth root of a to the m. And all you would have to do to apply this, if I had 7 to the 2/3, that's going to be the 3rd root of 7 squared. You can use this frontwards and backwards. If I had 10 to the 3rd square root of, that's going to be 10 to the 3/2. So if you have a fractional exponent, you can change it to a radical. If you have a radical, you can change it to a fractional exponent. This is going to become very, very useful here in just a little while. So let's look at some application of the rule. This example 11, page 54, we're given 343 to the 2/3 power. The denominator of that fractional exponent becomes your index. So it's going to be the 3rd root of 343 squared. And we're just simplifying. 343 squared is 117,649. So is this a perfect cube? This is a calculator problem. So you're going to use the button for nth roots and find the cube root of 117,649, and your calculator will tell you that that's 49. What they're looking for here is to see, can you apply the rule? You're free to use the calculator for simplification. Example 12, page 54, and we have this strange looking problem, 4 over the 7th root of a squared. And it says write this using a fractional exponent. So in other words, they don't want a fraction, they want a fractional exponent. Well, first let's get rid of the radical. Now 4 is a whole number, so it's fine. Your index becomes your denominator and your exponent becomes your numerator. So in fractional form, you've got a to the 2 over 7 power, or a to the 2 sevenths. Now it says as a fractional exponent, so they don't even want a fraction at all. How do you move something with an exponent to the other side of the fraction bar? Usually you're undoing this, but the way to do it is to add a negative exponent. So if I make this exponent, 4 is going to stay where it is. I'm going to bring a to the top of the fraction bar, and to do that, I'm going to make the exponent negative. Usually you're taking negative exponents and you're making them positive. Well, this time they want you to move it to the top of the fraction bar, to the other side. So that's when you use the reverse application of negative exponents. Now we're on example 13a, page 54. 13a and b are our last two examples, so they're going to kind of roll everything all together. So let's see what we have here. They want us to simplify 5 times 2x to the 3/4 times 3x to the 1/5. Alright, you have parentheses here, but there's no addition subtraction in there, so these parentheses are really just to separate our factors. And factors can be rearranged. That's your commutative property. So I'm going to go through here first. I'm going to multiply all the whole numbers together and get rid of them. 5 times 2 is 10, times 3 is 30. Now I need to multiply x to the 3/4 times x to the 1/5. Well, what do you do when you multiply two bases with two exponents? You add the exponents. So I have 3/4 plus 1/5, which is not great because it's fractions, but you have a calculator, and like I said, this is college algebra. Use that calculator. When you add 3/4 plus 1/5, you get 19 over 20. Done deal. Nothing else here will simplify. Last example, 13b, page 54. I've got 16 over 9 to the negative 1/2 power. When you have a fraction raised to a negative power, when you have a number raised to a negative power, we discussed this, that means put it on the opposite side of the fraction bar. Well, if you have a fraction raised to a negative power, then both of the numbers are on the wrong side of the fraction bar, and when you move both of them, you're just going to flip it. Now, you still have the same exponent, it's just that it's positive. So that flipping it, all we did was change this to a positive exponent. Now, the denominator becomes the index in your radical. So I have 2, and remember, if it's a square root, you don't really have to put the 2, but I will. And we're going to have 9/16. Whatever that numerator is, it goes there. Since it's a 1, 9/16 to the first power is just 9/16. So we are just ready to simplify square root of 9/16 at this point. You can use your quotient rule, which says find the square root of the numerator over the square root of the denominator. And it's really nice because both of these are perfect squares. So your final answer is just 3/4. And like I said, these examples was not so much about the math as it was about knowing the rules. Alright? In this prerequisite section, remember, what we're doing is we're trying to gain speed, gain confidence, and find and fill in any gaps that you might have. So if you found some gaps, let's fill them in. For an assignment, I suggest you look at page 55, 56 in the book, and I suggest you work all of the odd ones. Check your answers in the back of the book. If you're not getting the right answers, Then you'll want to work some even ones and come check with me. I'll give you some extra help and some extra practice. See y'all in CA 8.